This is our pre-calculus review of solving equations with a graphing calculator. I'm looking at the Unit 3 test that was given on March 10th. Here's a copy of the test. And we're going to be looking at these types of equations and how they can be solved. So this is an exponential component. This is an algebraic component. And whenever you have, and this is actually called a transcendental function. A transcendental function and an algebraic function, if they're in the same equation, generally speaking, this cannot be solved, analytically. You can have as much time in the world and as much paper and pencils as you want, and you'll never be able to solve this exactly for X. In advanced courses, you may be able to get an approximation as an infinite series, well beyond the scope of this class. Generally speaking, when you have an equation like this, and all the ones on this page, again, transcendental and algebraic, these are two transcendental functions. Now, this is purely algebraic, and if you know how to solve a cubic equation, this can be done with pencil and paper. I don't think we teach this at all, certainly not in most high school classes. Same thing here. I don't know how to factor x cubed minus x minus 3 is 0. So that's a hard thing to do. There are techniques for doing that, but we don't learn them in high school. Same thing with this one. But if we look at these first three right here, and in fact all the ones on this page, the intent was to solve them with the calculator. You're going to get approximate solutions. Each one should take about 20 seconds. So here's the first equation. You go to your graphing calculator, you enter in the equation, e to the x. Now, what we really want to do is find the 0. So I'm going to move the 2 to the other side and move the x to the other side. So effectively, what I'm doing is I'm entering in this function, y1 is e to the x minus 2 plus x. Here's the graph. The standard window is a good one to look at. We note that there is 1, 0. So remember, the 0 is where this crosses the x-axis. That's called the 0 of the function. So if we want to make this equal to 0, the calculator will do that for us. The calculator finds zeros pretty easily. So we want to figure out where this graph intercepts the x-axis. So second, trace. It's option number 2, which is the 0. The dialog is I need some number to the left. Any number to the left, -3 is certainly to the left. If I hit enter, you see the little arrow there. The newer calculators actually put a vertical line. I need some number to the right of this 0. I'll choose +3. Okay, so now I have an arrow over there. Again, the newer calculators will have a vertical line. For the guess, I just hit enter one more time. The program says, there's my 0. So for this problem, I can simply write x is equal to, now technically it's approximately equal to 0.443. I did in the directions say you need to round to the nearest thousandth, and this is rounded for us. You can set your calculator to round. It's under the mode menu. Go back to mode, and notice that here I've got it set for 3 decimal points. If it's in floating point mode, which is the default setting, and we were to do the same problem, second, trace, 0. This time I'll choose -5 and 5, -5 and 5, okay, and hit guess. So notice that now it gives me a more accurate approximation, 0.4428, but the direction set round to the nearest thousandth. So even though this is more accurate, 0.44285544, right? To follow the directions, there's tenths, there's hundredths, there's thousandths, because this is bigger than 5 or 5 or bigger. This has got to round up, and so we get 0.443. Now, if you actually on your test wrote x is approximately equal to 0.4428, I probably marked it wrong because you didn't follow the directions. You did not round it to the nearest thousandth. So please just follow the directions. It's not a hard thing to do. Okay, so all of these problems go very, very quickly. Here's the second one. Okay, the second problem was this cubic up here. Right? Again, we're going to move everything to one side. And by the way, as these may not be exactly the same problems you had on your version, there were 3 or 4 different versions of the test floating around. But let's suppose we had this guy right here, where we've got x cubed minus x squared is equal to 3x minus 5, and the task is to solve it. Let's see how quickly I can do this. I type in x cubed minus x squared minus 3x. Remember, I have to move that over, plus 5. Zoom 6 is my standard window. I see 1, 0. It looks like it's over here. Second, trace 0. Some number to the left, negative 5 is to the left. Some number to the right is positive 5. Guess, and there's my 0, negative 1.919. But I've got to round, right? So let's make sure we round correctly. X is going to be equal to, oops, let me bring that back up, and there's my smart screen. Okay, so for this problem, we have x is approximately equal to negative 1.9196. This is going to kick that up. That's going to kick that up. So I should have x is approximately negative 1.920. That would be the answer to the nearest thousandth. Now again, if you're rounding challenged, just put it in 3 decimal point mode. You can go through this whole little exercise again. Second, trace 0, negative 3 to 3, there, and it rounds it. Now, don't write negative 1.92 because that's only to the nearest hundredth. I don't know what this next digit is unless you tell it to me. So please go ahead and do that. Rounding and accuracy of approximations. Okay. Here's our test again. We'll try the sine one, and then we'll try the log one. So I'll do 3 and 4 and see how quickly they go. Okay. So here's the next one I want to work. Solve the sine of x is equal to x cubed minus 3. For the non-trig people, this is the sine function. It's on the calculator. Anybody that's gone through trig already knows this. So here's my y equals. The sine function is the second button in the 4th row. Sine of x, you have to close that off, and then move the x cubed over, so minus x cubed, and then move the 3 over, plus 3. There's the picture. Okay, it crosses somewhere between 1 and 2. So second, trace 0, left bound 1, right bound 2, and guess. Okay, so I've got it rounded for me. X is approximately equal to 1.587. I actually prefer floating point mode so that you get the best approximation that you can get. By the way, in calculus, all of these preliminary type calculations, and we'll do negative 5 to 5. All these preliminary calculations should be carried out, to the nearest 10,000th or even 100,000th, so that the final accuracy, or the final answer, has an accuracy to the nearest thousandth. You generally don't want to round until the very, very end. So here, 1.587, the 10,000th place is a 3, right? 3. So we're just going to drop that, and then there's our answer. So yeah, get used to rounding accurately. Okay, 4th one. Here's the 4th one in my sample test. Right, it's a log. This is base 10. This is a common log. Log base 10 of x plus 3 equals 2 to the negative x. So solve log base 10 of x plus 3 is 2 to the negative x. And even though we've done a unit on logarithms and exponentials, this cannot be done by hand. You're going to have to do the approximation. So log base 10, that's our common log, x plus 3. Subtract off the 2, raised to, then I'll wrap that in parentheses, negative x power. Okay, so here's the graph, standard window. It looks like it crosses somewhere around the origin, second trace 0. I'll go negative 5 to 5, and there's my 0. So x is approximately equal to 0.789. Done. Now, any equation can be solved on the calculator if there are real solutions. So if I said solve x squared is equal to 9, well, I would certainly trust that you know the answer is plus or minus 3. I mean, that's sort of a duh thing. But let's pretend we were being really silly and we just wanted to try to solve this on the calculator. So you type in x squared, right, move the 9 across, and then graph it. We see 2 zeros. This is obviously our parabola, right? This is x squared minus 9. So it's a parabola shifted down 9 units. There's the graph. And the zeros. Okay, so there's 2 of them. We have to find both. And we'll do the one on the left first. It's between negative 5 and negative 1. Okay, you see the arrows appear. It goes back and forth between those 2 locations. There's 1 0. And the other one, between 1 and 5 on the right side. And 0. So we get x is plus or minus 3. When will the calculator not give you approximations? If there are no real solutions. So let's suppose we had x squared plus 1 is equal to negative 4. Negative 4. Okay, and I ask you to solve that. Now, there are no real numbers that when you square, you get a negative. So the calculator won't help us here. Right? If we try graphing it, we'd have to move the 4 across, so that becomes plus 4. Here's the picture. Obviously, there are no zeros. There are no real solutions to this equation. So follow the directions. If it said solve using real numbers only, you would have x squared plus or minus the square root of negative 4. This is not real. Not real. So you would have to say no solution. If they said find solutions that can be complex, x squared is negative 4. X is going to be plus or minus the square root of negative 4. And you know from your algebra class, that would be 2i. So there are 2 solutions, complex numbers, but you can't find them on the calculator. Okay? So I hope that helps. If you still have trouble graphing and finding the solutions to equations using a graphing calculator, you need to find somebody. These 8 problems in this test should have taken less than 5 minutes. Basically, you type it in, graph it, find the 0, write the answer down. Okay? So one more just for practice. We'll actually see how quickly I can do this one. Okay. 2 raised to the negative x plus 3 power minus 1/5. Zoom 6. There's the standard window. It looks like there's a 0 off there to the right. I'll find it. It's somewhere between 1 and 9. And there it is. X is equal to 5.322. So X is approximately equal to 5.322 rounding. Done. Go to the next problem. Okay, let me go ahead and stop this little video here. And happy equation solving.